using lenses. After knowing the focal length and the object's distance, we can find the position and nature of the image by drawing a ray diagram. How do we draw a ray diagram? Let's see. So, as you can see here in figure 1, the object is beyond the principal focus, F, and the lens is a convex lens. Therefore, we are sure that the image formed will be a real image, first of all, and it will be away from the principal focus F here on the other side. Let's see where the image exactly will be. To locate the image and determine its nature, 3 main rays are used as construction lines from a single point of the object. This point of the object, ray 1 will be drawn that is parallel to the axis, and then after passing through the convex lens that has outward arrows, it will refract through F, right? Because the rays will converge until they meet F. And then ray 2 that passes straight through the center of the lens, and it does not change its direction because the lens surface at the principal axis are parallel to each other, so the lens will not cause any change for this ray that passes at the center of the lens. So we'll elongate it, and at last the third ray that starts from the same point of the object as we agreed, and it passes through F, the principal focus of the lens, until it reaches the lens. So how will it refract? It will refract parallel to the principal axis. And therefore, the meeting point of these 3 converged rays is the image of the point that we originated these rays from. So what do we conclude? We conclude that the image is real, but it's inverted, as we proven by drawing the ray diagram. It's upside down, unlike the object, and it's smaller than the object, as you can see. You will think, where is this case used? It's used in cameras. In a camera, a convex lens is used to produce a real image of an object on a film or on an array of pixels for a digital camera. The position of the lens is adjusted to focus the image on the film. So, in a camera, just like how we said, for a distant object, the distance from the lens to the film must be equal to the focal length of the lens. So, for a distant object that is far away, the image will be formed at the principal focus, that is in this case the film. So the distance between the lens and the film is then equal to the focal length. While the nearer an object is to the lens, the bigger is the distance from the lens to the film. So if the object is nearer to the lens, as in the case that we drew the ray diagram for, then the distance between the lens and the film will be greater than the focal length.